Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and today we continue with our topic of discussion, and the topic is genetics. We have covered a number of items on genetics, and today I would like us to find out how you can determine an unknown genotype. Determination of unknown genotype. For example, in some of the examples we've seen in the past, we saw that the garden pea, for instance, if it is tall, you may not be able to know whether that tallness is as a result of homozygous condition or is as a result of heterozygous condition. But now you can be able to determine whether it is actually homozygous or heterozygous by carrying out a number of tests that we shall see. So one of the ways of determining of unknown genotypes is by doing something that is called crossing with a homozygous recessive. Crossing with a homozygous recessive. For example, I may have a tall plant, like I've said, but I don't know whether that tallness is as a result of the genotype, capital T, or is as a result of capital T, small t, because in both cases they are tall. So what we observe the phenotype, the outward appearance. And in this case, the outward appearance is telling us they are tall. But we want to find out whether that tallness is as a result of this genotype, that is capital T, or it is as a result of the genotype of this kind, which is capital T, small t. So we can do that by crossing with the homozygous recessive. If we cross the homozygous recessive and then we get all tall, that means that genotype was the first one. If we cross with the homozygous recessive and find out that we are getting all tall plants, then it means that the first genotype is as indicated. But if we cross with the homozygous recessive and we get a mixture of tall and dwarf plants, then of course we know that then this one must have been the genotype. So that's how we are saying that by crossing with a homozygous recessive plant, then we can be able to know that the genotype was either homozygous, like in this case, if we get all tall plants, or if we get a mixture of tall and dwarf, then we actually know that the genotype that was appearing tall was heterozygous. Now, I would like us to see how we can demonstrate these kind of crosses, and we'll assume both scenarios. We'll assume the first scenario and also the second scenario. So for instance, if it was the first scenario, then we'll say that the parental phenotype, remember we always start with the phenotype before we go to the genotype. So we are saying that the phenotype is tall against tall. And then the parental genotype, we are saying that now we assume that the tallness is as a result of the first case, which is homozygous. So we assume it is that, just a moment, we are crossing with a homozygous recessive, so we are crossing a tall and a dwarf. So the first case is a tall, then the second case, a dwarf, will be small t. Then in terms of the gametes, we show the gametes, we circle them, and we make sure we don't puncture the gametes. So we can either do the genetic cross or we can use a Punnett square. So let us use the Punnett square. And on this, we'll have something like, assuming the first plant was the male and the second was the female. So we have the female and the male. Those are the symbols that we use to represent. So the tall one will have T capital. The dwarf one will have T small. So when you do the crossing, then that is the F1 genotype, or the offspring's genotype. Then we are saying that the phenotype in this case is all tall plants. So we are saying that if we get all tall plants, then it means that the genotype was homozygous. It was capital T, capital T. Then we are crossing it with a homozygous recessive. Now, if we assume the second scenario, that if it was tall, but it was in a heterozygous state, then it means that we are going to get a mixture of tall and dwarf, as we can see. We'll again start with the parental phenotype. So we are saying that the male is tall, the female is dwarf. The parental genotype will be now capital T small t, again is small t. We do the gametes. Then again, we can also use the Punnett square or the checkerboard. So here we have tall, small t, that is tall dwarf. Here we have small t. So in this case, you can see that we have got a mixture of tall. These two are tall, these two are dwarf. So we said that if it was a heterozygous state, we will get a mixture of tall and dwarf. So here, the F1 genotype as indicated. So the phenotype is 2 tall and 2 dwarf. That is a mixture. The ratio, the phenotypic ratio is 2:2, which we simplify as 1:1. So that is what we have just confirmed, that when we are determining an unknown genotype, we can do a crossing with a homozygous recessive. Homozygous recessive is this. So either if the genotype was heterozygous, we'll get a mixture of tall and dwarf. But if the genotype was homozygous, then we'll get only tall plants. So that's one of the ways of determining an unknown genotype. The second way of determining the unknown genotype is selfing. And selfing is crossing the unknown genotype, whatever we are trying to investigate, with one like itself. With one like itself. And on this, we are saying that if we get only one trait, for example, only tall, then we know that that genotype was homozygous. So, but if you get a mixture, again, we know that it was heterozygous, just like we have done in the previous case. So we are saying that when you obtain only one trait after selfing, then the genotype was homozygous. The genotype was homozygous. But if you get a mixture of traits, that is like the tall and dwarf together, mixed together, then the genotype was heterozygous. The genotype was heterozygous. So selfing is crossing an individual with one like itself. And we are saying that if it is homozygous, then we'll just get that one trait, only tall, for example. Or if it is the color of the flowers that we are investigating, then you'll only get like red. Now, but if you cross and get a mixture, then we know that the genotype was heterozygous. So that is by selfing, crossing the unknown genotype with one like itself. And then the third way of determining the unknown genotype is something that is called back-crossing. Back-crossing is whereby you cross, is the crossing of one offspring. You take one offspring, you cross it with one of the parents. You cross an offspring with one of the parents. So if, for example, if I was to take an offspring here and then I cross it with one of the parents, then it means that that is back crossing. I'm doing a back crossing. I'm going back. So that's what we refer to as back crossing. So selfing, back crossing, and crossing with the homozygous recessive, they are ways of determining the unknown genotype. And we basically refer to them as test crossing. We are testing. We are trying to find out what is the genotype. So you'll have an assignment. So the assignment, the first question, name 3 ways of determining an unknown genotype. 2, using a Punnett square, determine the genotype of a heterozygous tall plant by selfing. So we'll stop there. Until next time, goodbye.